Hi, and welcome to another episode of Force Tech Talks. We're very excited today. I'm here with Ben, who is our applications manager and has to suffer with me daily, talking about some of the topics we're going to discuss. We thought today we would talk about long-term storage. So a lot of conversation is going on in the industry at the moment around last time buys, last options to secure products. So we're getting a lot of questions about long-term storage. What is it? Lots of kind of FAQs around it. Can my product be stored? Things like that. So thought that's what we're going to talk about today. So I wrote down a couple of FAQs that I've kind of been hearing the most when talking to customers and prospects. So the first one would be, why would an organization choose long-term storage for electronic components?
Yeah, I think the first point about that is that, it's the most guaranteed way of ensuring, continuity of supply. If you can store the original component that you were using on your PCB, then you can continue using that that component. Obviously, you can store in die or package form, and there's various complexities with both. But it's the number one way of resolving obsolescence. But it does take that forethought to and expense. You've got to go out there and buy the components and put them in stock and know they were going end of life in the first place, of course. But it is the most optimal way to secure your project.
Yeah, it does require quite a level of proactive kind of thinking and resilience, or even being aware that there is an obsolescence issue that's coming up or kind of hits you overnight. So what would make long-term storage different from, say, just a standard warehouse that someone would use?
So the concern with semiconductor components is, especially in plastic form, and in wafer form as well, is that they degrade over time if not stored in the correct conditions. So, your standard warehouse conditions, if a part's not in a moisture barrier bag, it's going to be suffering the room humidity that it's currently in. And all plastic parts, as a lot of people know, have a moisture sensitivity level. And that's really because moisture ingresses into the and permeates through the plastic, and can cause damage internally within the component, as well as causing other issues. When you sort of heat the chip up and put it through a reflow, you can get an effect as well documented called the popcorn effect, which sort of, as the part outgasses the sort of moisture that's internally within the component, it can sort of shatter the plastic. But really, it's if you're keeping it in a standard warehouse condition, it's gonna deteriorate. It's a very difficult thing. Semiconductors have only been sort of around in the last 50 or 60 years. So there's still a lot of juries out on and it's very difficult to do, long-term studies, over 20 or 30 years, to sort of see how chips degrade over that period in various conditions. And obviously the industry's been doing the best they can to sort of resolve that. And we'll talk about that later. But in terms of sort of how the difference between warehouse conditions and sort of long-term storage conditions. The long-term storage conditions are in cabinets that have a stable humidity, stable temperature, and can be flushed with nitrogen or not. And obviously nitrogen being an inert gas prevents oxidization and other sort of forms of degradation that can be caused by sort of intermetallic growths and things like that.
Whole world of issues when they're exposed to the elements and sit on a shelf.
Effectively,
And I guess that's okay for certain kind of shorter term projects or parts that are being turned around quickly, but for the long term and the longevity of the parts, it's definitely makes a difference. Another question I hear quite a lot is, I've got this chip, this part number, this semiconductor, is it appropriate for storage? So I guess what kind of components can we actually store in long-term storage?
Yeah, it's quite a wide-ranging question. I mean, certainly plastic components are the first ones to sort of point the finger at as being the most sort of delicate over long-term storage, and that's because they're not inherently hermetic. So they have ingression of moisture, and they're not fully sealed to the outside atmosphere, or certainly the internal chip cavity is not sealed to the outside atmosphere. So all semiconductor devices can sort of are subject to long-term storage. Yeah, plastic might be the most sort of sensitive in that regard, and then obviously wafers as well, which is the internal silicon within a component. So yeah, plastic devices, wafers or die, ceramic components. Whilst if they are hermetically sealed to mill standards, you don't have that risk of moisture getting into the device cavity or any kind of atmospheric concerns. And to a sort of lesser extent, any kind of sort of intermetallic issues, because they've been sealed, they've been nitrogen flushed prior to seal, so you shouldn't have any kind of concerns there. But you still run into, can the leads degrade in any way? A lot of ceramic components have gold coatings to mill standard, so again, that's a sort of thing prior to them being tinned that covers their it's gold and being an inert metal sort of stops oxidization and things like that. So really the answer to that is everything in ideal situations is suitable for long-term storage. You do want to control your temperature, your humidity, and not have them exposed to oxygen or any other sort of atmospheric conditions that could cause a concern. And then you've got materials on top of that, your sort of raw package materials, things like lids and that kind of thing. They're on relatively short lead time, and they're just sort of a simple enough component that you can just sort of order them readily when you need to do builds. But anything that doesn't have an inherent expiry date, certain things like epoxies and die attaches and things like that, they're readily available, and won't go obsolete in that regard. So I think
it's essentially anything, isn't it, that could affect
pretty
the
much,
build of the part or the part itself later down the line.
That doesn't have an inherent expiry that that you have to be aware of, sort of thing, that might degrade the material.
The another question that I hear a lot, and it's a tricky one to answer for a few different reasons. Semiconductors haven't been around for that long. There's kind of not a lot of longitudinal data on how they perform and how they degrade over a long period of time. But how would someone ensure that whatever you're storing is fit for use when it comes out of the storage and it's being required down the line?
The best way to do that is data, and data can be collected in the form of, if you've built a batch, or if you're buying a batch from an OEM, you're going to have a set of characteristic data from that, and if you've done a good sort of parametric capture of that, you're going to have a good set of results that as your starting point
can test against.
And
later.
Then once you look at your sort of the duration of the storage you're going to need, is it a 10 or 20 year storage or less, then you can build a plan that makes good sense, sort of maybe every 2 or 3 years, take some devices out, put them through an electrical test.
See how they perform.
See how they perform. You could go right up to the extreme in a very, very critical environment, say a flight application. You could look at taking a small subset of devices out of storage and destroying them through a life test. So you could put them through a 1,000-hour or 2,000-hour life test to make sure, that's the real sort of absolutely on the extreme end. But, you can really scale up and down. And when we store components for customers, we look at building a plan that makes sense. There's no point spending hundreds of thousands of dollars or pounds, testing these devices if you're storing them for a 2, 3, 4, 5 life cycle. But once you go into your 10 and your 20, then you really want to put in some really solid breakpoints there, to really know exactly that the parts aren't degrading, that they're going to be solderable when you put them on your boards, and you're just going to have no issues when you take them out of storage and call them off and put them into production.
I think another conversation that we're often having with people who are, say they come to us and say, right, we've been issued with a last time buy, we have to make a decision, and they're thinking about the quantities. We would always say, don't just look at what you need for production, kind of build or buy extra, because you never know, how your quantity and how your demand is going to change over the life cycle. But also think about having extra so you can do some regular kind of milestone testing and it doesn't degrade from your production quantity.
Yes,
so
that's
that
a very
is
important point.
yeah, bit of a good advice there that we like sharing. So in terms of industry standards or best practices, can you talk a bit more about the industry standards?
Yeah, so there's two main ones, I would say, or two main organisations at the moment publishing guidelines for long-term storage. That's the JEDEC specification, namely the JEP 160, and the IEC specification. It was predominantly aimed at long-term wafer storage, which is a somewhat different ball game from storing components. The sort of JEP 160 mainly talks it does mention wafers, but it is mainly aimed at sort of plastic storage conditions, and then what kind of moisture sensitivity level they are, and then ensuring that they're stored in. So, for example, a plastic device, you're really going to be wanting to keep it under 5% RH, because that gives it an indefinite shelf life. All of these standards talk about storing product in moisture barrier bags, so it's kind of a belt and braces operation. So you seal the parts in a moisture barrier bag, purge with nitrogen, and then put it into a cabinet, and then store it, and then periodically monitor it. But yeah, so it's something that, semiconductors have only been around for 50 or 60 years. It's something it's an ongoing process. There's very limited amount of white papers on semiconductor long-term storage, but there have been there's been enough data collected now that we know that you can put semiconductors into storage now for 20 or 30 years, and know at the end of it that they're going to be still serviceable.
Fit for use. Fit for use. How would we maintain traceability and documentation over time? Because obviously, paper and electronic versions of documentation, and if you are looking at like 10 to 20 years, it's very easy to kind of things get lost or things don't get scanned, so how would we tackle that side of it?
Yeah, I think we've got a very solid stocking system. It's important that when documentation comes in that you do the correct level of checks to make sure that you've got the correct level of documentation coming in at that point, because we see customers all the time that they bring us a wafer and they've someone's thrown a bit of paperwork away that might have been the original CFC or packing note originally, and they've lost the traceability right from the start. So again, draw a line in the sand in the same way you do it with your electrical data capture. Make sure you've got all the relevant documentation. That documentation rides alongside the components in ESD bags, and stays with the components in their location. And if the components come out of that location, the paperwork comes with it. It's logged out in the same way that the parts are logged out and then returned. Having suitable scans of everything as well, having electronic copies of everything, because paperwork itself, it's human error. It's easy for a bit of paperwork sometimes to get lost. So having additional backups of everything and a good multiple backups of things is very important. But yeah, it is just a consistent case, and it's if you're storing something with a company and that company goes out of business, making sure they've got a suitable,
data retention policy.
Data retention plan. So we've got an indefinite data retention plan. That's important. We've been around for nearly 40 years now, but making sure that you've got that full traceability. Traceability right the way back to day one.
The worst thing, I guess, is you do store something for 10 or 20 years and it is fit for use as we would expect it to be, but a page is missing off a document, a traceability document, and then that renders that potentially unusable. And we do see that it has happened to customers. So it just,
in aerospace environments, a single bit of paperwork loss could, especially in flight critical applications, means you can't use that product anymore.
So you want to make sure, yes, you're doing a good job actually storing the parts. They're in all the right conditions, but you take them out and you look at the documentation and think, this is going to be an issue. Another question is, can customers access or recall stock quickly if required? That might be one for me, but essentially, yes. It's your your stock, it's your product. You can access it and recall it as and when you want. Something I heard the other day was a customer said, "Oh, you know, how many months do we have to give you notice? Do we have to give you to recall our product?" And I said, "Not that long." I said, "You know, depending on how much you're recalling, you can give as little notice as you want. It's your product to recall."
I mean, it's important in that regard. The only other sort of factor in that is if customers are, it's how the parts are packed. You know, if you've got tubes of components or trays of components, especially parts that have extremely delicate legs, you need to make sure you've got the suitable packaging materials. But that's something that you think about, you know,
at the start,
when you're building your plans prior to it. It's like, how many are they going to be calling off? And it's good for customers to think about, well, if I'm, you know, I need 20, but, you know, they're in trays of 50, for example. You know, what are we going to do with the additional units? Are they going to sit on a shelf somewhere? Is that going to degrade them in any way? And there are standards, certainly on the JEDEC side of things, that cover that. So it's just, you know, making sure customers are mindful of that and building the correct plans at the start. And
planning it from the beginning. And a question we always ask is, what is your call-off schedule? And, you know, you can build the best call-off schedule in the world, but if 5-10 years down the line, quantities are changing, demand is changing, and you need less or more, then try and make sure that everyone's thought of that at the beginning of if things do change, as they do in the semiconductor and aerospace world all the time. Just building that in from the start. Like
but I mean, and at the same time, just being flexible. You know, I mean, we are flexible. If a customer changes their requirements, we understand it, and we'll adjust and be malleable to that. So
a final thought before I release Ben from all these questions. Can you store customer-owned inventory or only parts you supply? Both.
Yeah.
We can do both. A lot of the time it's customers that are being forced to do certain last-time buys or certain purchases that therefore it is their own stock, their own material. But it can also be stuff that we aid in the supply of, and we kind of, you know, suggest certain routes. So both. And that comes back to the flexibility aspect of it. It's not for us to say and make the final decision of what a customer should and shouldn't store. We can only kind of guide of what we think would be appropriate and what we've seen other best practices from other customers, kind of best industry practices. So anything.
I think it's important, especially if we're storing stuff that we've assembled ourselves, then we know we've got the correct documentation and traceability chains, but and the electrical testing sort of data capture. But if you're storing sort of a customer's material, then we need to, you know, if they don't have any kind of trace or electrical documentation or test documentation, then we can put plans in place to sort of, you know, test that product and give them that line in the sand to start off with. And of course, if customers waive that, then, you know, you're sort of guaranteeing your storage conditions through read and record and then doing sort of, you know, periodic testing on it. But it's
just tailor it to the customer, whatever they need, the project needs, what the part is. There's so many kind of factors that go into it that is kind of the fun of planning a long-term storage project. Sometimes it's, you know, what are all these considerations? Let's discuss them. Let's get them sorted right at the beginning so you don't get any surprises down the line.
Yeah, it's definitely not just bung it in a cabinet and see if it works at the end of it. There's a lot to it.
There's a lot to it. There is. Right, well, that will conclude today's episode of Force Tech Talk, and we look forward to seeing you on the next one. Thanks.
Thank you.